Well, good evening. We've received quite some pressure there, and a few disclaimers. I've already broken 2 of the rules, as I forgot my badge in the hotel, and I have lost the program as well. So I guess we couldn't start any better. And there will be a lot of information here packed. I've got about 45 slides for about 25 minutes, which is usually a recipe for disaster. But anyway, my affiliations: I am a neuroscience research fellow at the University of Melbourne. I have a Bachelor of Science in Pharmacology, a PhD in neuroscience with subfields in pharmacology, neurophysiology, bioinformatics, and artificial intelligence. So I'm a multidisciplinary PhD, and I'm the founder and CEO of Somnivore Pty Ltd, which is a machine learning company providing artificial intelligence to laboratories working on the science of consciousness, from psychedelic science to drug discovery and sleep science. Right, so I have quite a keen interest to study the mind and to work out how to deploy it for a better future. And I have stumbled upon many disciplines that could help us in do this, and myself. And I could identify at least 6, there's many more, and they all have their own pros and cons, advantages and pitfalls. The first and foremost that actually approached this was philosophy, which is very advantageous in many ways and a total disaster in every other one. It's very unconstrained. You can have a shower and have a fantastic model just developing before your eyes. And it's very fast and very imaginative, especially if you're under the effect of psychedelic substances. There's a few pitfalls there. It's extremely subjective. It creates so many models, and most of them cannot be approached with technology in a way to validate them. And one of the most uncomfortable problems is that all the philosophers that manage to create models that can be tested eventually get a real job in a real department and cease to be philosophers and then become engineers or something like that. Then psychology, of course, another low-hanging fruit. The first approach, parascientific approach to the study of the mind. And it started very well with very keen scientists that just wanted to really study behavior, because psychology really is the study of behavior. But then a major disaster occurred to psychology, which undermined the whole field, and she hasn't really recovered yet, which was psychoanalysis. Unfortunately, psychoanalysis is not really a natural science, an hermetic science. So it relies on stories and these narratives, these crazy discombobulations that cannot really be tested, like with Freud, the birthing phase, the anal phase, and all these things that are kind of cute, but then kind of dissolve at the level of modeling. And problem is that, again, it's scientifically weak. It's very hard to reproduce most of the studies. And the meta-analysis occurred about a few years ago, maybe 2 or 3 years ago, actually. Discovered that 90% plus of all the participants that ever went through a psychology study were all college students. In fact, the majority of them were American college students. So we're trying to understand the underpinnings of how Homo Sapiens work, and we only really study a very subset of the population for a very specific ethnic group in a very specific time of their life. They don't even want to be there. They just want $50 to buy food or drugs, and so it's kind of cumbersome at the level of studying how the mind works. Right, then we've got neuroscience, probably one of the lowest hanging fruit. I have a PhD in it, so I'm relatively fond of the practice. And it's the first fully scientific way to study the mind. There's problems there as well. Over-reliant on animal models, because it's a bit cumbersome. You kind of have to take skulls, drill them, open them up. There's bits of brain splashing everywhere. It's kind of awkward. And in the last few decades, unfortunately, it's become harder and harder to do this on humans. So neuroscience kind of got slowed down in the process. And in many ways, it's also an indirect approach, because it works mostly at the level of implementation. We mostly study what really means to be a neuron or a brain as opposed to a mind, and we don't really have any specific evidence to really assume that the mind really arises from the brain. It is still an assumption within science, but neuroscience is very important, and of course is something that is cardinal to the full stack. We just need to move further in some way, because studying neuroscience to understand the mind is a bit like trying to understand hydrodynamics in fish by observing their scales under the microscope. You could have a bit of an idea, but it's a bit vague and a bit indirect. Anyway, so we've got other things like pharmacology, of course, neuropharmacology. You just blast brains with drugs and whatnot, and then see funny things happening. And I'm a big fan of that, especially since I had to take one for the team during my scientific journeys. But I've also understood that in many ways there's a lot of noise there. And also you're flooding the whole brain with a very specific compound which never really occurs in normal, with neurotransmitters really, which is localized, a very specific time fashion. And it's not like that. But it's very important because it enables us to disable and strengthen specific neural networks, which then can give us some kind of idea of what's going on in the brain. Then we've got electrophysiology, things like neurofeedback, and you're just attaching a lot of electrodes on someone's skull and then trying to augment that brain wave or the other brain wave. That's also very powerful, but it's very superficial. You can't really get inside the brain unless you have epilepsy, and again, they open your skull up and whatnot. And so, yes, there's that as well. Then one of the lowest hanging fruit now today is computer science, because computer science can really help us model almost anything now. We've got the computational power, and software is more or less ready, and the funding bodies are there to deploy resources towards it, and it can bring forth philosophy, neuroscience, and psychology even to actually create systems that can be tested. So how do we do this with computation? So the most basic thing one can talk about when approaching systems is information, really. And information, according to Shannon, and even experientially, really, can only really be defined at the most basic level: differences. Differences is information. If there is no difference, there's no information. We cannot even talk about it. And brains become usually blind to a state of no difference. Then we go states, which are set of discernible differences, or patterns of differences. And the computation is the description of how these states change over time. Consciousness, there's many definitions as people, but under my frameworks, consciousness is anything that can acquire information and decide outcome, really. So mine is pretty broad. But then, yes, the operating system of anything, really, from an organism to matter. Mind is more like an app over consciousness, an epiphenomenon that observes the universe installed onto consciousness. Intelligence is the ability to make models. What's a model? It's a description of relationships of specific states in a system, usually adjacent, and how they develop over time. And the function is that specific relationship. So artificial intelligence is one of the most recent ways to really try to model the whole thing, because we've seen that artificial intelligence can do things that organisms can do too. So we are starting to observe a decoupling between intelligence and consciousness as we define it as humans, meaning that more and more things that before were only in the domain of human consciousness can now be done with other entities that, according to our assumptions, do not have a human consciousness, but can still drive cars, play poker, or buy stocks and whatnot. So it's kind of a big deal. So we've got at least two big branches in AI: rule-based, symbolic system, expert systems, giant webs or if-then statements, like trying to replicate an expert's mind into code, and then machine learning, something that learns from data. Different branches within machine learning. This is technicalities, something that can learn from things it doesn't know anything about. So I can tell that is different from that. Then there is unsupervised. Then supervised, you're trying to teach a system what two things that you know about look like cats and dogs. Then you throw unlabeled instances there. What's that? Oh, it's a cat or it's a dog. And then reinforcement learning, one of the most powerful today, where you basically don't have anything. You just have the most basic algorithm there, and you say, I want more of that, I want less of that. And that has bestowed upon us things like self-driving cars and very complex things. Anyway, cardinal premises of AI mind modeling is that minds are information processing systems. And computer science appears to study information processing systems, which is kind of ideal in many ways. This can then leak into philosophy. This was all extrapolated from a 3-hour talk I gave 3 weeks ago. I said, I apologize if I'm running from things to things. I'll try to lubricate as much as possible. But this basically tries to then make sense of what computation can do for the nature of reality as we think of it. And a bunch of geeks came up with computationalist functionalism, which is something I partially abide to myself, which basically states that reality as we know it is a dream/hallucination created by the brain, placed in a higher place of existence. This higher place of existence is actually the real world. But all our perceptions, ideas, mind and self are placed in this dream/hallucination. Ground reality in the physical world isn't accessible to us. What does that mean? Well, through our eyes, we can really capture a little bit of a little bit of a little bit. It's been estimated that across our entire life, our visual cortex will be hit with 2 terabytes of information. That's nothing. Your entire life condensed in 2 terabytes. When we can only see the real surface of things with a specific wavelength of light that hits in, and hits us, it's meager. There's almost no information there. We are capturing less than 0.00001% of what we consider reality, and then we're making all the other assumptions that we operate to stay alive. So that's kind of a problem when we really want to be sure about what's going on in the world. So basic requirements for consciousness, as I understand it, and some other engineers, we need all these things, at least these things, to really have a conscious system. Let's start with global functions. Global functions is basically, global transition functions is basically a behavior that takes a state to another state, right? The laws of physics, of the universe, or whatever God told whatever to happen. And in fact, that it was the very first underpinnings of theology, trying to understand why things develop in the way they do, really. Because back in the day, we didn't really have an idea. There's thunders, causing fires, or all of a sudden someone dies, or I don't know what's going on. I need stories. So there's different layers of religious overbearing over the mind, or at least a logical mind, starting from bottom to top. The highest degree of theology is usually placed upon religious gods, the most traditional of gods, the ones that are institutionalized, like the Christian God or Buddha, or they usually are anthropomorphic in some sort of sense. They seem to care about you somehow. They, even though they've created the world and the laws of the universe, they seem to really, really, really be passionate about knowing what you eat and how you dress and whether you masturbate or you do not masturbate. So that is the religious God, really. Then we transition to a lower degree of religious thinking, which is the spiritual God, the one that transcends institutions, that is there somehow. It's not necessarily a person or person-like thing, but it may care about you somehow. But we don't know, really. There's no label on it. That's more like the psychedelic God, the sort of thing, the spirits that you see on DMT, and that kind of transcendental feeling that there's something past us and these things talk to us or whatever. That's a spiritual God. Then we jump, a big jump, is the God as a transcendental principle. A champion of that was Thomas of Aquinas, which basically just said, there must be something out there other than nothing, because there's stuff happening, right? I have no idea. I can only assume that there must be something out there dictating meaning in us, really. This is one of the cheapest gods we have. It's just like, there's something there. There's some sort of meaning in anything that happens and anything we believe in, and that's where I stop, right? That's your very last line of defense against nihilism, in which there's no meaning. I could just lay on the ground and rot because I am just a speckle of dust floating through space. Then we go on the very first degree of theology, really, which is hardly theology, is the first mover, or Aristotle's God, which basically said, if I do this and I move this thing, even though there's nothing to move, just imagine it, I'm moving it, right? But then something is moving my leg, or across over the moment I was born, there's something eventually that would have started that motion, right? And Aristotle called the first mover. So the first mover was not moved by something else, he just decided to move, all right? That's the underpinning, what we call in physics the singularity, right? It's that, before everything, there's just this thing. Before this, I have no idea, right? And that is the first mover in theology. And we could also extrapolate this at the level of entropy, because everything spurs from it in that direction to time and space. And that could be and that's actually, entropy is more like the devil more than the god, because it usually fucks things up, like destroys things, things of fire, things break down or rot because of entropy. And neg-entropy is more like what we consider God. It creates order in things, and anyway. Yes, let's start a little video to basically try to understand global transition of functions, as I mentioned at the beginning, that dictates basically the behavior of things. This is DNA polymerase within cells that is copying DNA. You can see that he's basically reading this tape, and then whatever, it ended there. So there's this tape, it gets read, and it gets replicated, and then when you see, it looks very much robotic, right? It's very deterministic. There's some probability there, but there's still entropy bathed in the whole thing. But you can see that it's basically operating in a very predictable way. And that's our understanding of the most basic molecular biology. Then, and that's basically everything that we consider life cells. And inside the cells, that's all there is, really. There's all these things moving around, just taking more little bits and pieces, copying things. It's very robotic when you can see it, really, when you can get to that level of magnification. Then, I'm trying to get, whoa, no, go before. Anyway, I need a slide before, or just it jumped a bit too much. Anyway, what you're seeing here, is the Conway game of life. I'm not sure, has anyone here ever heard about the Conway game of life? Oh, one person, that's cool. So the Conway game of life is this absurd thing invented by this scientist called John Conway. It's quite interesting. My flatmate in Australia actually was named also John Conway, and he was a comedian, but I realized that this John Conway was also quite into his humor, because he created this weird game where there's just pixels, and they either die or are born, according to rules. Like, if there's, and these rules are more or less the ones the neurons also abide to. Like, if there's nothing alive around the live pixel, it dies of loneliness. If there's at least 2 or 3 live neighbors, it stays alive, all right? Because it's got neighbors. If there's nothing alive, but there's 3 live cells around, a new entity comes up to life. And if there's too many, 2 or 3 live neighbors, 4 live neighbors to one, that one dies of overcrowding. So you see these pixels just basically developing over time. That's the most basic conformation. It's called a floater. And it copies itself and floats through space, always going back to the first configuration. It's very weird. And you can see that has some kind of behavior. But what happens when you just throw a lot of pixels in there? You actually see them, and this is a self-referential function, a bit like fractal dynamics. And you see very weird things when things become self-referential. So let's go to the actual video thing. So this is actually a longer, a much more disturbing video that we could only really chop into a few seconds. You can see all those things there, creating these columns, and then you see that there's that thing there spitting something onto the other one that eats them, and then it spits something back. And then there's basically all these kind of pseudo-creatures being created. And this becomes majestically big and weird, and I can't really, there's a thing, all of a sudden they chase each other. Like, nothing like that was really ever decided. Somebody just threw a bunch of random pixels in there, and they seem to just spontaneously form into weird live kind of forms. And it's a very simple game. It doesn't really pretend to generalize for the laws of cellular biology, but you can see that there's something happening there. And this is a very, very 4 simple rules. It is quite attractive to think that the subatomic level, very simple set of rules, and quantum mechanics really states that the universe really, it's created out of a very, very simple algorithm. And then we're trying still to work that out, but the simpler the better. Anyway, boom. Systemic boundary. The systemic boundary is the very underpinning of duality, meaning I am and that is not me, right? You need a systemic boundary to be able to capture information, to transduce information from the outside and make meaning inside, right? So the systemic boundaries of these neurons, it's basically the outside. They communicate. You can see that there's just a few levels of magnification over what I showed with the robot thing, and you can see some sort of behavior, like the gregarious neurons there that do their thing. Then there's the introvert up there that just moves around, and every now and then it just goes back to the crowd and says, "Oh, I'm still here. Please don't kill me," because this is what happens if you're too isolated. The brain usually kills you. So there's like an ecosystem there. They're trying to basically maximize reward at the expenditure of negentropy for their own vision of what they're trying to do. And this has been quite neatly converted into electronic models. And there's a paper that describes, for the ones of you that are brave enough. Feedback loops. So we need feedback loops. 5 minutes, that's not going to happen. Feedback loops, we need things to be self-referential at the level of what they do in the world and have some kind of reference of whether what they do is good or bad or conducive to survival or death. So these neurons usually eventually conglomerate into more complex structures. At the level of the brain, we see things like the brainstem. And this is like the ultimate feedback loop. Almost none of this is conscious. Because in many ways, one of the theories of consciousness is also that it handles broken models. Because at the moment a model has been established, it doesn't need to really be figured out, and it slips into the unconscious. You don't need to be conscious about how to regulate your bowel movements or whether your skin sweats or not. All these things are kind of like figured out. And they become unconscious. Anyway, this is like the most basic of feedback loop. This chicken survived for like 2 years after his owner chopped his head in 1945. And the whole brain was gone, but the actual brainstem. So it's actually pretty cool. And it made the dude about $50,000 a month in revenue in today's money because he said, I'm just going to set up a freak show out of this. And so it's actually pretty crafty. Anyway, then we've got more complex feedback loops. This is a limbic system that governs sadness, jealousy, envy, and all these primal emotions that then can govern both cognition and regulate some of the more primal feedback loops. This is a cat without cerebral cortex that only has the brainstem and the limbic circuits. And it's very funny because it basically went, according to any kind of stimulus, even the mildest, it went into this thing called sham rage. And it goes like this, and nothing else other than this, right? It wouldn't even attack because it didn't have the brain to really plan any kind of attack, but it would just go into rage. So in many ways, it's kind of interesting to see that the default mode of a cat devoid of the cerebral cortex is actually rage, and it's not love. It's actually quite interesting. The default is actually that, at least for cats, anyway. Anyway, cognitive brain. This gets far more complex. This gives us personality and whatnot. We don't have time for that. And then local functions, dual frameworks, right? Intelligence alone will not make you get up in the morning, not do anything, right? If you're extremely intelligent, you won't actually do anything. Intelligence is not enough. You need motivational systems. And motivational systems are dependent upon the full stack of neurology. And this has been modeled with AI, and these are some of the things that are required to have motivational systems. Feelings of nurturing, of legitimacy, dominance, affection, exploration, arousal, water, food, and then it gets even more complex. From information, patterns, to patterns of patterns, into simulations, into knowledge, which then top-down affects information, all of this. Anyway, this is a silicon-based mind. And AI is getting closer and closer at doing this. So at the level of integration, which is the step after, as said here, local functions. These are basically the things do this because otherwise that's mostly survival, right? For our understanding of evolution. Then integration is different communities of neurons or biological systems like the kidneys or the liver communicates and integrating information across all the systems. That seems to be an obligatory step towards consciousness. And we see things like Giulio Tononi from Wisconsin University modeled this, he called integrated information theory. It says the more different parts of the brain talk to one another, the more consciousness, right? And they studied this and evaluated it in people that just came out of coma. At the beginning, it just zapped their brain with transcranial magnetic resonance. And it saw that during coma, nothing would happen. The actual stimulation would stay there and just a little blip, but that's it. After 11 days, the stimulation would actually spread across more structures. And after the person actually came back to cognition, the whole brain would light up. So you can see that there is actually some kind of integration within the things. And this has also been observed a few months ago in 2019. It's actually pretty neat. And more theories like the global workspace of consciousness integrates all these things and brings them at the forefront of behavior. So you should be taking care of this, you should ignore this, and whatnot. Boom. Anyway, then carbon. Is that carbon necessary for consciousness? This is like one of those intrinsic debates within people. So, the good Michael Russell from NASA just said the purpose is actually a very profound individual and real comedian. The purpose of life is to hydrogenate carbon dioxide. It's just, when you think about it, it's just, oh wow, that's profound. And it is very profound. And when you think about it, actually, Michael isn't completely delusional, because when you think of anything that has consciousness, or we think has consciousness and lives, there's always carbon there, right? When you try the level of infinite regress in epistemology to go back at the level of meaning of what is thinking, boy, so I think I have consciousness, I go cogitus sum, I think that person has consciousness because he behaves more or less like me, I can only make this assumption. And then I say, do babies have consciousness? I'm not sure, sometimes they don't look like they have consciousness. And it says, yes, then where does that come from? The fetus, the egg and the sperm, and then comes out a soul, right? They talk about the soul and all these things. But where does the soul come from? So I don't know, it just comes out, right? Or it doesn't just come out. There must be something conscious-like within sperms and eggs. And I say, but what about sperms and eggs? Where does it come from? I don't know, like there's some molecules coming together and then consciousness comes out. That's the soul, just whatever, right? Whatever. And you can go regress and regress at the point in which you can only really talk about carbon being hydrogenated, because before that, it's just, there's no difference between an organic thing and that pole over there. So it's, oh God, so you just said, that is the purpose of life, then is to hydrogenate carbon dioxide. Interesting. So we are now entering into the realm of panpsychism, which is a specific frame of thinking that I also abide to a large extent, where it basically dictates a consciousness and inherent properties of anything that is governed by any kind of law of physics, including physics themselves. So then you could think, if this is really the underpinning of carbon-based consciousness, unless we really want to create a theological layer around carbon as an atom, maybe other elements have their own consciousness. It's pretty plausible to think so, unless we want to be monotheistic about carbon, right? So maybe silicon has its own consciousness, who knows? And in fact, we see it behaving in weird ways when provided with the facilities. So this brings us to weak computationalism, which basically thinks minds are algorithms realized in biological hardware configurations. Mental content is represented in these algorithms. Perception encodes information given at the systemic boundary of the mind as a mental content. Thinking, feeling, dreaming are aspects or operations of a mental content. This is the weakest form, then it can get even far more spastic than this, and we go into strong computationalism, which says that everything is an algorithm, including the universe itself, because in fact, everything seems to have functions, right? In how things behave. So reality itself is an algorithm. All the university can present us is information and regularities in the information. So there must be transition functions there, dictated by something, right? No conceptual difference between reality and a computer program. So this is like a schematic around it from back. And there's a universe that has its own algorithm. And that is based upon the global transition function, which we do not have access to. And we've been trying for decades, if not hundreds of years, to extrapolate it. And we've only really come down to quantum mechanics and general relativity and some broken string theory in the middle. And that's the human mind there, which is basically just something that is trying to work out and translate the general algorithm, which is based on its own transition functions. Anyway, how good are silicon-based minds then? Well, they're getting increasingly good. IBM here beating Kasparov. This was like a big thing. Then here, Google DeepMind learns from nothing to play Breakout and Montezuma Revenge, which is actually a very hard game. And in Montezuma Revenge, you start seeing the AI developing his own intuition. He starts jumping for no reasons, he explodes chambers just like a kid, It's actually very interesting. Then we've got Deep Stack, which now is unbeatable for poker players. And for this specific version of poker, there were 10 to 160,000 possible playing configurations, which is actually double as many atoms in the known universe. So this is pretty remarkable in thinking that an algorithm managed to learn this and become absolutely unbeatable in just a few days of playing against itself. And then AlphaGo, where there's like this game, very popular in China, it's part of their culture. 19 positions versus 19, black and white tassels. And again, many, many folds, more movements as the atom in the universe, considered to be like a state of mind more than a game. You have to enter this state of trance. Like this is, only humans can do this. Well, until Google AlphaGo came into place and beat the unbeaten Chinese champion. They started crying because he just lost his identity to an algorithm. Then AlphaZero versus Stockfish. Stockfish was it grabbed the legacy of IBM Deep Blue and incorporated the entire history known to humans about chess. Every single champion, every single whatever, even like all the speckles that could be gathered from the internet about the history of the known strategies around chess associated with Homo Sapiens. And AlphaZero knew nothing. And beat Stockfish 28 times and tied every other game, so he did not lose a game. And guess how long it took for AlphaZero to learn the entire history of Homo sapiens playing chess? Playing against itself? 4 hours. In 4 hours, it did it, right? It was like 4 hours. And this was like 3 years ago. With today's computers, maybe 2 hours, right? The whole history of chess gone, right? And at this point, humans are gone already. Because this is not humans again. No, this is AI against AI. So we've already like, okay, cool. There's then StarCraft, for those of you know, it's basically a life. You don't know what's going on. You have to have intuition about what the other player is doing. There's more combination than Go, 1,000 order of magnitude. It's not times, it's far more than times of Go. So this is basically impossible to code at the symbolic level. And you have to guess, you can't move slowly, it's in real time. Outcomes of moves takes hours to work out whether that was good or not. With chess, you make a move, 4 or 5, I think I messed up. No, that 4 hours, you don't know what's going on, whether that was a good or a bad idea. All these things, and 7 months ago, and it was also handicapped to match the clicking speed of humans. Again, like it beat everyone. So this is basically like a good modeling of someone's life. And this is starting to get kind of spooky. So now we go into altered states of consciousness, another very dear practice of mine, academically and personally. Meditation, ecstatic practices, fasting, breathing techniques, psychedelic substances, extreme sports. Injects noise, entropy, and stochastic resonance inside the system. Augments the divergent thinking, so they have more models. And then it keeps the ego adapting. It needs very careful management. This can tap into the last 3 of, potentially even the other 2, but let's just talk about the other 3. So this important paper from Robin Carter Harris talked about entropy in the brain with psychedelics. You can read it because it's a mammoth thing. You know, I don't have enough breath for it or time. And this is psilocybin that basically showed how different parts of the brain integrate more, therefore potentially more consciousness, even though this has not been proved, because even for Tononi, MoFi has been cracked with algorithms. So, you know, there's some benefit of the doubt there. But anyway, this is a level of creativity, is like some kind of holy grail and can provide a lot of information. This is basically what AI is doing internally during those 4 hours of going crazy playing against itself. It's basically that. And so at the level of default mode network, which is the neural network within the brain, that governs identity, goes down, and then it goes up again. So why bother? The last slide is important. Why bother? Why bother? It's the last slide. Go back. So why even care about doing this? At the personal level, there's, of course, an epidemic of mental health issues, which are governed by many, many problems within society, mostly disconnection, loss of meaning, and this is just going to get worse. You know, but back in the day, we're mostly the product of hundreds of thousands of years of hunter and gatherer psychology, now extrapolated into trying to find a good a parking spot, or like raises at work in terms of wages, or just like, you know, Candy Crush saga on your phone is alien to us, really. So we are becoming more and more dehumanized, which is a problem. And also, because of AI and disruption, we are going to incur into more problems at the level of loss of meaning, because AI is basically going to annihilate most of the working class and the middle class at the level of jobs. because AI is becoming better and better, doing almost everything. So it's basically progressively going to make humans more and more useless, really. That's the problem. And since we are so intertwined with our job, you know, when you present yourself, you ask my name, my surname, and that's what I do, really. It's basically your second surname, and some people even place it first. I'm a psychologist, and this is my name and surname. So once that's gone, you know, what are people going to do? You know, this is going to be actually pretty cataclysmic. And so we need to understand more and more how the mind works, at least to kind of stand some kind of competitive chance against AI and even ourselves, because we've already dehumanized ourselves through the supply chain of industrialized jobs. So it's kind of tricky. And then at the level of global decay, of course, there's planetary alterations like climate change. We've destroyed most of the planet. Biodiversity has collapsed. Millions of species are gone. We kind of need to try to work out what's been happening for the last few hundred years that's caused this quantum leap at the level of overall annihilation. So this is where my company is trying tentatively to do something about it, which is basically aiding the studying of consciousness in research labs working on consciousness, which spans pharmacology, psychedelics, sleep, mental health. And it does this through AI. So itself, it facilitates the work of scientists that otherwise spend hours or days or weeks or months doing very menial things that a machine knows to do much better. And so it removes these tasks off their back, which is usually a pretty bored and jaded back, and gives them the opportunity to do better science, more exciting stuff with their day-to-day operations, and also saves money and whatnot. So this taps into at least the 4 layers at the bottom. Of course, computer science, electrophysiology, because it can aid the neurofeedback research and more electrophysiology, pharmacology, you know, it already does it, and neuroscience, of course. The first hurdle has been overcome with this publication that I managed to put out in March this year in collaboration with Harvard, Oxford, the University of Melbourne, Bologna, La Trobe, and SRI International in California, which basically combined the validation of the level of sleep science across mice, rats, pigeons, and humans across all sorts of conditions. So it's now very strong to be deployed into what I call the gateway altered state, which is sleep, and then progressively approach all the other altered states for our own benefit and globally. Anyway, these are my contacts, academic, somnivore related, and my LinkedIn. Anyway, thank you.